Ravichandran D, the Senior Manager Product Management Mesa Cutting Systems India Private Limited. Mr. Ravichandran D is presently associated as Senior Manager for Product Management at Mesa Cutting Systems India Private Limited. He is a 1989 batch graduate in mechanical engineering, and he has been active in new product development for nearly 25 years in the machine tools, automation and thermal cutting industry. Today, Mr. Ravichandran will talk about material handling and automation. So let's welcome Mr. Ravichandran.
Janak has showcased the laser cutting machines and the capabilities of those machines. And you have the machines cutting 24/7 plates. And the way to increase their productivity is to handle the materials that's going into the machine and taking out the cut parts out of the machine in a seamless way. So if you have automation to handle the plates and the materials which are being cut, that will greatly enhance the cutting process. And also, apart from the material handling, if the process itself is being digitized in the sense, like when you start the process, you have to plan for the process, you have to plan for the raw material, then you have to move the raw material, then you have got to do the scheduling, and then you got to check what nesting plans have been cut and what parts have being cut out, and you got to take an inventory of all those parts. And if those activities which are day in, day out being carried out in the shop floor on a regular basis are manual, then it takes a tremendous amount of manpower and effort. And if those activities are streamlined using an automation system, then the process becomes very, very simple. Now, there are two cases where two major attributes to enhance the productivity of the laser cutting. One is automizing the material movement, and the second thing is automizing the process. So first, let me showcase automizing the material movement. Suppose if you have the raw material feeding in, and then you can either store it on a vertical storage, which will give a benefit of literally reducing your horizontal space by at least by around 50 to 60%, and then the inventory getting managed very well, because all the materials which are stored vertically are actually managed by the ERP system. So it's like benefit both ways. Either one is your process gets smoother, and the second one is your inventory is getting managed effectively, and your space or storage space is reduced very much, like somewhere around 50 to 60% of your storage space gets reduced. And also your time to store the plate and retrieve the plate becomes very simple, and also time is very much reduced. So here I'll just run a video wherein you can see how the raw materials can be stored vertically, and then they can be retrieved and fed to a machine for cutting. So this is like storing a bundle of sheet on a pallet on a vertical storage, and then the machine, when it's programmed, it retrieves the pallet where the required material to be fed to the machine is being pulled out, and it is taken to the other side of the tower, which will be the processing site where the machines are present. So here the machine is finished the cutting. The unloader picks up the material which is being cut and drops it into a platform, or it can be a platform or a trolley, or it can be under or a cart, which I'll explain it to you later. Then it picks up the fresh raw material which has to be cut by the machine and can be fed into and that can be fed into the machine. And if this is happening on a machine which has got a shuttle table, so when this process is being done, the machine is already cutting the previous plate which is being fed in. And this change of material, like lifting off the cut parts off the machine and feeding a new plate will happen in a matter of minutes, say maybe 2 to 2.5 minutes. And that's how the time is reduced. Now we have seen a version where you have a single system which is unloading the cut parts and then loading the fresh raw material in. So the time taken is slightly increased. Suppose if there is a customer who wants a system which can load the material within a minute or so, because their cycle time is much faster. So we can have a system where we have the loading and unloading of the plates separately. So this is like a system which I want to showcase a very large plate being handled, say suppose 6.3 meters by 2.5 meters. This is a simulation video of what we have just shipped over to USA, and it's like storing a bigger plate. And this pallet has got a capacity of 5 tons, and sometimes you can have a pallet capacity of 7 tons also. So you can have 10 pallets, 15 pallets or 20 pallets depending on the height availability of your shop floor. Suppose if the standard height of the shop floor which allows the crane movement is around 5 meters. In that 5 meters you can have a pallet up to 10 pallets. And in totality, 10 pallets into 5 ton capacity per pallet, you can store 50 tons in one tower at least. And now the pallet from which you have to load the sheet, it's similar to what the previous video which I showed, but the only difference is we have a separate unit which loads the sheet metal. So you can see this loader has got an array of vacuum pads which picks up the plate, and you can have a capacity up to 5 tons. So it picks up a plate, and in the meantime the material which is being cut on the machine is picked up by a fork, double-sided forks patterned unloader that goes down. The fork goes inside below the opens up and goes below the cut plates, picks up all the parts including the remnant or the skeleton of the cut plate, and it moves out. And if you now see, the moment the cut parts are picked up, the loader comes and loads the material. So you can have a sheet cut sheet being taken out and a fresh sheet being loaded in say around a minute or so, less than 90 seconds. So your machine is up and ready for cutting in less than 90 seconds. So this increases the productivity of the machine. Normally in a machine like this, if you have a plate cut, then it takes more than 15 to 20 minutes for the cut parts to be removed, and then a plate to be loaded onto the machine will take another 5 to 10 minutes. So the machine will be idle for at least around 20 to 25 minutes. So in that 20 to 25 minutes is being saved by having a separate loader and unloader. So it means the machine need not stop maybe a minute or so, and it can again start cutting. So this is like this type of automation system enhances productivity with the same machine. So this material handling systems also can be clubbed with the storage systems. So it's like we have got 2 types of classification based on the version. We have got, if you can see at the bottom, we have a single unit which unloads and loads the fresh plate. This we call it as a base version. And other system which has got a separate loader and unloader, we call it as a premium version. Premium because it reduces the non-cutting time to be a very minimum. So we have named it premium, and also it can be of like with CE certification, CSS certification, and UL certification can be had. These systems can be had with all these certifications, and the basic version is for Asia Pacific region, mostly targeted for Asia Pacific and the Asian countries, wherein CE certification is not needed. And we have an intermediate version wherein if suppose somebody from the Asian countries wants a faster change of plates and raw material, we can have it the same unit like the premium but without CE certification, just for the cost benefit. Then based on capacity, we can have two sizes. That's a material handling system within 12 mm capacity, and the other one is 25 mm or 40 mm capacity. And we also have on request plate handling systems up to 50 mm thick plates. And these are the specifications, whatever it's shown. Like we have in 3 sizes for the sheet application, and we have 4 sizes for the plate application. So it starts from 3 meters by 1.5, 4 meters by 2 meters, 6.3 by 2.5, and 7 meters by 3 meters. So you can have plates handling up to 10 from 10 mm, 12 mm to 40 mm and 25 mm also. And the storage towers, we can have standard pallets up to 10, or we can have 15, 20 or 25 based on the configurations which the customer needs. So it's like, this is what we call as a full system, where we have the storage, the material loading and unloading systems, and the storage system has got a loading station where the store, suppose in case the operator is near the machine, the storekeeper comes and loads the material, and he punches in the system what material is being loaded in what pallet. So it's like one pallet will have a unique size of material, and the quantity is also entered by the storekeeper. So when the operator wants to work on a particular type of material, the system automatically pulls out the required pallet and keeps the pallet to the other side, wherein the raw material is handled by the operator to the machine. And fencing, and the other one is basic version, where we have without the CE markings. And this is a full-fledged system with storage tower, and you can have a standalone material handling system also, where we will not have a storage system. And this is the economical version, where suppose if in a shop floor we have a different types of machines, like other than the laser machine, you have a punching machine, you have a shearing machine, and you have a turret punch. So if the material has to be fed to all the other systems, you can have a storage separately, and then the material handling can be separate, dedicated to those machines. So you can have a bundle of sheet below the loader on both versions, or you can have a cart, so the man doesn't move underneath the material handling. So material handling system is like enhances productivity. It provides a safe operating atmosphere near the machine, environment near the machine. So in the days to come, like now, the what I would say is laser has played a major role in converting the sheet metal working process to a very simplified process of laser cutting. Because earlier it has to be shear, it has to be punched, it has to be deburred. All those processes have been taken off by laser cutting, and now even plasma cutting is slowly getting converted to laser cutting. So the cutting process is nearly getting stabilized, and now the trend is for the industry to move towards automation in terms of material movement. And these type of material handling system will definitely enhance productivity, increase the productivity, and it will benefit the customers a lot. And apart from these, whatever material handling systems I had showed you earlier is for a standard size of machine. Suppose if we have a gantry type of machine, which is the machine length can be 10 meters, 12 meters, 20 meters. So we can have a smart crane. It is just a crane on a gantry with a vertical slide, and on the end it has got a magnet pickers. So this can be automized or semi-automized. So an operator can also operate, or else it can be totally automized, where it can go one step ahead of the earlier shown material handling system, wherein this can load the material and also pick cut parts one by one and stack it in the pallets where it has to be stacked. So it can be used for loading and also picking up cut parts and also the skeleton. So this can be an added advantage to the industry, wherein the parts are also stored the way it has to be stored. So it can be gantry. It comes in various sizes of 4, 6, 8 and 10 meters width. And the maximum capacity of one single picking tool is 1.2 tons. That's 1200 kgs. So if you have a bigger plate and a plate is weighing around 3 tons or 5 tons, you can have number of additional picker gantries working in tandem. So that is one. So it can load material, and the main important thing on a smart crane is it is basically designed to pick parts. Okay, loading raw material is a secondary operation, and other than that, the end of the arm has got a C-axis rotation. So after you pick up the material, it can be rotated and oriented to adapt your what you can say is your pallet, the cut parts pallet or a bin, whatever it is. And then this can be a offline equipment which can be retrofitted to existing systems also, irrespective of whatever process it is. Either it can be an oxy-fuel cutting machine, it can be a plasma cutting machine, or it can be a laser machine. So this has also got a camera on the top which sees the components and sees the orientation and adjusts itself. And also it behaves with respect to the nesting program which is already made. So configurations, it can be a single gantry with a single pick or a single gantry with a double pick. And these combinations can lead to double gantry with single pick or double gantry with double pick. And you can also add on gantries based on the size of the raw material and the weight of the raw material also. It can be one picker in one gantry, two picker in two gantry. It's highly configurable. It can be for whatever length you want, machine, say starting from 6 meters to 24 meters, and the width can be from 4 meters to 10 meters. The end of the picking tool is by magnets. So you can have a matrix of magnets, or you can have a positioning adjustable magnet array also. So these are just to show you the weight carrying capacity. And this is like showing how a cut part is being picked up. Being cut. Marking portion is also defined, and this can happen automatically. So this shows like you can pick up cut parts straight away. This is showcasing only a single picker. Now you can see a double picker. Double picker in this case, in this particular application, the plates are fixed and they are placed in a roller so that it is being transferred to a straightening machine after being cut. Otherwise, what the single components can be stacked one over the other. So these are the two types of material handling systems, one for the standard size of material machines and one for large format machines. So this gives out various options of handling the plates. Like one is before cutting and after cutting, how the parts are being removed from the machine and they are stacked up. So this can increase productivity, and another major thing is this gives us an option where the dependency on labor is reduced. And this is one, like material automation, material flow automation. The other one is the process automation. It's like using digital technology to automate the process. The process is always the same. Like it's like you want to cut a plate, you have to make a nesting plan, you have to feed it to the machine and then select a database and select the process what you want to cut, and then you got to cut. So this is not going to change. But the thing is, if you are able to automate, then it avoids errors, human errors, wherein the different nesting is taken for a process other than the one which is already planned, or else the cut parts, like whatever is being cut, that has to be fed manually to the ERP system, and there can be a human error in that. So all these things can be taken off by our OmniWin and OmniFab softwares. OmniWin and OmniBevel is a nesting software for the straight plates and the bevel cutting nesting software. And OmniFab is our automation software, which can be used in these machines. So the normal conventional way of working is you have a nesting plan, feed it to the machine and do the cutting. Okay. And the exchange of program can be through a LAN cable or through a pen drive. But when we do it, the normal customer queries are, how do I stop or save the manual steps which are being followed in the data exchange process, or else is there a doubt where whatever I planned is really happening or not, and are the jobs cut in priority, and are the reports after being cut or the deviations of the cut parts are being fed into our ERP system, and how well my machine is utilized. And if there is a downtime, what are the reasons for the downtime? Will I have the data of my downtime available for analysis so that in future I can bring down the downtime? All these things are in the mind of all entrepreneurs and the shop floor people, and whatever they do, they start creating data on their own, either by writing it or on a spreadsheet. They put all the data so that they want to reduce the downtime and they want to automate the data flow process. So we have got softwares which can help you to automate this. So it can automate the process, digital transformation, and in that process you learn what are all the bottlenecks available in the processing program or in the workflow even before you actually do the process, and real-time feedback you should get. And when you get a real-time feedback, you plan in such a way that you will have on-time delivery, and the process should be highly transparent, should have high transparency so that you know what is happening at any given point of time in your shop floor, and the cutting process is effectively under your control. So this is the workflow what we have. You have the order management, that is from the ERP, you know what you want to cut or process, and then you have to prepare for the cutting process, like prepare your nesting plan and have your material ready. Then you should plan which parts or which nesting plan should go first based on your factory requirement. Then you should automate your machine operations, get a real-time feedback, and after you do that, then you have to analyze how effective you have used your machine, or how what is the productivity level, all those things. So this is what happens in an industry day in, day out, using various methods. And our system, we have a system where we call ERP Connect, wherein the order management, like right from the ERP flows into our system. Then we have the OmniFab, wherein if you are doing it for a third party, you can also get the process cost, which can be converted to quotes. And then your job management is the planning scenario, where you can schedule your job and which plate has to be cut in which machine or which process and in which priority and sequence. And then we have the material flow, wherein it can be integrated with a material handling subsystem. Suppose you have a material handling system based on your job management, the required plate should come from your material storage. So all those things can also be had automatically. Then the PDC is after the material is being cut, the feedback of what parts are being cut and the quantity of it and how many parts are being passed out. Like suppose if you have no deviation, the amount of material or the job which is being completed should go back to your system automatically. So the moment the machine stops cutting, finishes cutting, the material, the data is fed inside based on the nesting plan which is being used. And we have another system which gives you information on the utility of the machine also. So it's like real time. In real time, you will know how far the machine is being utilized and what is the downtime and the reasons for downtime. We can pre-feed all the downtime possibilities, and then the operator can feed in the downtime to assign it to the defined reason, and we have a real-time feedback of the machine, and this can be transmitted through the web to your laptop or to your mobile, and that can be viewed by the supervisor or by the plant head or anybody who has access to the system. So this is like automizing the process. So this will reduce manual errors, and it will effectively help you in planning, and will also give you feedback whether the process is happening as per plan, and above all, apart from the process, how the equipment is being utilized, whether it is 100% utilized or if there is a downtime, why there is a downtime, either it's for material, either it's for operator error, or it's a problem from the machine itself. So that will help us analyze and rework our processes so that the machine can be utilized effectively. So it's like what Janak had said about the laser machines, and then I had spoken about the automation on material movement and automation on the process. So this is a trend which is coming up in the laser industry. That is, apart from the machines, which has high productivity and which has got enhanced methods to increase the productivity, and the add-ons like the material handling and the process automation. Yes, the key benefits of the process automation, that is OmniFab ARA, that is all the running process you can know about all the running process at a glance. You can have it as a worksheet, or you can have a dashboard sort of presentation, and all these information can be passed on to all the stakeholders, so everybody get the real-time feedback, and the machine can be, or the process can be scheduled, and you can have a feedback whether the orders are happening as per the schedule, and then you can also simulate and see how, that is, when you schedule, you can simulate and see which is the best way to schedule or best sequencing to have. And also you can get the process cost from the system, and anything can be planned well ahead so that your process is happening seamlessly. So this is what is about automation, and these are all the modules which we have for automation. And this is all. Thank you.